Peter Wairagala. Please take it away.
Yes, thank you so much. Let me share my screen. Please allow me to share my screen from the side. Yes, thank you so much. Yes, so today I will be presenting a paper on gender bias evaluation, machine translation for Luganda to English. Yes, so yes, so the title of the paper is Gender Bias Evaluation, English to Luganda Machine Translation. So I work with the Makerere AI Lab in Makerere University, Uganda, in collaboration with the Macon Lab, still in Makerere University. So this work was partially funded by Lacuna, the Lacuna Fund. Yeah, so to kickstart directly, Uganda is a highly multilingual country with over 43, more than 43 languages with and dialects. Yeah, so with the growth of machine translation and natural language processing tools, building machine translation models has been a very slow growth in the country. So for this case study, we're going to look into Luganda, which is a language that is spoken by over 6 million Ugandans around the shores of Lake Victoria and towards Lake Echoga. So for this paper, we are particularly studying the evaluation of gender bias in machine translation of Luganda to English translations, given the fact that the language is gender neutral. With all languages in the country, they don't have pronouns like he, she, him, herself, himself, and so on and so forth. This makes it very extremely hard while translating sentences from the local context to languages with gender-specific pronouns like German, English, Spanish, and so forth and so on. So where there's bias manifests itself, specifically this happens a lot when translating sentences that are in the occupation domain and the cultural domain, whereby all the historical data is driven to show that some occupations associated to female and also some other occupations like doctors, engineers, and classes like subjects like science subjects are associated to male, the male stereotype instead of the female stereotype. Yeah, so for this case study, we try to cover as a bigger ground as possible while collecting the data. So the sources of the data were the social media platforms in the country, newspapers and blogs, and also PDF books for the language Luganda. So the first idea was to collect the monolingual corpus, the English monolingual corpus, and later on this was translated into apparel corpus. So what happened, most of these sentences were copyrighted. For example, if sentences were collected from newspaper websites, they have their data copyrighted. So we tried to create the data set in CC0 license as possible. So we provided the English monolingual sentences to motivate or to prompt the creation of new sentences that were later on translated into Luganda to create a parallel corpus. So training the models, we try to leverage transfer learning on the Marian-MT models, particularly as you see here, the Helsinki, just to try and train a simple model that we can use to evaluate our work. So we achieved a blue score of 26 for the English to Luganda model and also 24.6 for the Luganda to English model. So we trained, we didn't train particularly like a multilingual model with other languages. We specifically put all our attention on only one pair of languages or one pair of languages. For example, these ones are just examples of the translations that happened after training the models. As we can see, we have some sentences in the local context, given the fact that Uganda is is a country that is eats everything from agriculture. We gain everything from agriculture. So we try to cover as more ground context as possible during the collection of sentences. So the most biggest part that I actually want to talk about is gender bias in Luganda to English languages. As I mentioned before, that Luganda is one of the languages in the world with gender neutral pronouns. When I say gender neutral pronouns, as I mentioned, the pronouns like he, she, himself, herself, and so the examples particularly are provided here in the occupation domain and also the cultural domain. For the source sentence, as we see here, it says, I tried to provide some simple graphics on how, because there are some people that don't understand, actually most people in this on this call don't understand Luganda. Sorry for that. So the translation for hospital is dualio, and the words or the characters in red, they mean that we don't have them in the source sentence. So mostly when translating from the neutral language to a gender specific language, we find ourselves having gender specific variants that are sometimes biased toward a certain stereotype. So as we can see here, the models, according to the historical data that was used to train the models are led to think that always doctors are supposed to be men. So in this sentence, particular row, the speaker tried to meant a female doctor, but the model understood it as a male doctor. And this is all in the historical data. So this is something that is happening all over the world in languages that are actually with gender neutral pronouns. Then the other important example is according to culture, somehow, somewhere, we are being led to think that, okay, female more suited for domestic work, and men are not suited to work in offices or something. So this information is being collected and stored somewhere, websites, newspapers, blogs, and all that. So this information was used to train models. That's why we find that when you talk about aspects of domestic work, the models tend to be biased towards the female stereotype. So, for example, the speaker meant he cooked food on Sunday for the children, but the model translated she gave food to the children on Sunday. So this is a high is an example of gender bias manifestation in the translations. And then, so to understand our data set, we try to come up with a simple regex expression algorithm to extract gender pronouns and understand how far is gender bias in our data set. So, but we couldn't do this on the Luganda set, on the Luganda monolingual set, because we didn't have pronouns, given the fact that the study is all about pronouns that influence the context of other sentences in this context. So when we looked at the pronouns in the data set that we used to train the models, we found out that the male stereotype pronouns are highly, the male stereotype pronouns are very much, there are very many compared to the female stereotype. And this is, the analysis, it is not 100% accurate because it didn't take into consideration of the sentiments and all that. So this data also comprises data from the Bible set that is actually always online and open source. Yes, so to do gender bias evaluation on the models, we try to leverage still the existing frameworks and try to tweak them a little bit to suit our context. So we use the word embeddings fairness evaluation framework with our own test sets. So what happened, we created a test set, a gender test set from the gender neutral sentence to the gender specific sentences in English, and to try and evaluate the models. Now, the word embeddings framework, word embeddings fairness evaluation framework has several metrics. For example, we have the word association test metric, which actually looks at the associations of terms between stereotypes. For example, we see that art-related subjects are highly associated with the female stereotype, and science-related terms are highly associated to the male stereotype. And this is all incorporated in the historical data that is always used to train these machine learning models. And then we compared our results with the Translation Gender Bias Index, still, which is open source. So it tried to look at how the index is, the tool tried to look at how they can evaluate gender bias in a language with the similar language with gender neutral pronouns also. Yeah, so for the word embeddings fairness evaluation framework, it takes in a query. So this query has the target attribute, and also it has the target set and also the attribute set. So in the target set, this denotes a certain group. Then the attribute set denotes the traits about a certain group. So for example, we have the target set, which is women, and we have several things that we have words that indicate that this is a woman, a man, so she, woman, girl, and so on and so forth. This is the same thing to men. Then association of traits, where do they belong? Mathematics, chemistry, then arts, poetry, something like that. So this, and at the end of the day, we provide results for four matrices. So what happened? We tried to look into fine-tuning already existing word embeddings. For example, the fast text word embeddings, maybe the glove trained by Twitter. We realized that in our context, some of these things are not really counting so much. So what we did, we trained these word embeddings with the translated sentences from Luganda to English from scratch, so that we have a well-versed performance, so that we can compare with. So we realized that on doing this, maybe first and foremost, maybe for the other matrices, the RND, the relative norm distance. So this looks at how it looks at how the attributes or the terms for the terms and attributes are really related using the distance. Then the RNDS looks at the sentiment, positive and negative. Then so if I go back to the other part where I was saying that the word embeddings helped us to look into the word embeddings that were trained from scratch helped us to get a full picture of how our models are biased. Yeah, it wasn't like the pre-training of already existing word embeddings. They already had also their own biases that would have been carried on to our results, and explaining them or trying to fine-tune the results would be a little bit tricky, given the fact that in this context we have pronouns that are he, him, himself, herself, but in the other context, some things may come in, and it will be a little bit tricky to give conclusive explanation for the results. Yeah, so as we can see, the results move from 0 to 100, of course, that is 100%. So we realize that all the WETES with effect size, which also looks at the association of attributes or the association of terms with how far are they associated to each other. So we see that this one is is very high for the skip gram word embeddings still, and also for the R&D, we see that it's also very high for the continuous bag of words word embeddings. And this is a very high indication that the models, of course, they were already biased, given the fact that the test set that was used to train the word embeddings was a gendered a gendered set in this case. Then for the translation gender bias index, the measure takes in a sentence S in which each sentence containing a pronoun with, of which the neutrality should be maintained in the translation. So for this case, we try to, what happens here, it takes in a sentence and looks at the sentence if it has the gender pronouns, and then aggregates them at the end of the day to provide us with a score here. Then, so we separated the gendered set into several classes, the occupational, the formal, polite, and impolite. So this was done on the translated set. And still, we compared the results on the Google Translate model to try and see how far the models biased. So as we can see here, the models that were trained on the data set that was controlled, of course, it is in our context. Yeah, so a disclaimer here, these models are different. So this is a Marianne empty model. Google Translate trained another model that we just try to evaluate and see. So we realized that either our models were biased towards a certain stereotype or something, and that's why we have a difference in the results at the end of the day, the average of the index scores. So the evaluation was used on the same set, but we got different results. So this is a high indicator in the difference, the indicator of bias in the data sets that are used to train these machine learning models. And this is something that is still going on in the Macquarie AI Lab to try and still understand how we can either try to mitigate gender biases or any other biases in the languages, because almost all the languages, over the 43 languages that are mentioned, don't have pronouns. So we compared this with the human evaluation. So a few sentences were selected randomly and provided to the linguists. So this work was done hand in hand with the linguists. So what happened was they came up with a simple conclusion about what they realized from the translations. So we, as I mentioned before, some occupations were highly associated to male, like doctor, engineer, whereas nurse, secretary are associated to female. And this bias is, as we saw before, it is highly incorporated in the data set. So hence the manifestation of gender bias in the results. So for the human evaluation, so specifically they looked at how models think about the male and female stereotype positively and negatively. So we realized that when we talk about beauty and wisdom, our model from the gender neutral source sentence, our model was associating beauty but not wise to the female stereotype, to the feminine stereotype, whereas wise and handsome or good was associated to the masculine stereotype. This happens because in the Luganda language, we certainly have the same words to mean several things. For example, if I say, for example, this word might mean wisdom, wise, it might mean good or good at something, then the sentence, this sentence, the word in blue.
Sorry, Eric, can you hear me?
Yes,
we're running out of time. Can you try to wrap up in 1 minute max, please?
Yes.
Thanks.
Yes. So the word in blue can mean good or bad. So the models were associating wisdom, but not wise, to the feminine, and then wisdom with good to the masculine stereotype. Yeah, so all in all, we realized that the results showed us that the models were biased towards gender in a way that favors the masculine stereotype. In this case, because the feminine stereotype is underrepresented in the training sets, and then the main cause of bias is always that the affect has no gender pronouns. Yeah, thank you so much. Any questions?
All right, let's thank the speaker. Unfortunately, we have no more time for questions, so please ask them in the forum. And let's move to the next Zoom room, please.